10.2, number 23. Find the unit vectors, 4 vectors in all, that are tangent and normal to the curve at the given point. Alright, so we need to figure out what the derivative is. So in order to find the slope, so dy dx equals dy dt over dx dt. So dy dt is 1, let's see, plus 2 square root of t is, let's see, 2, and then the square root of t is 1 over 2 square root of t. So it's just 1 over square root of t. And it's at 1. We'll do that next, I guess. Dx dt is 1 over 2 square root of t, derivative of 1 is 0. Okay, so plugging in 1, I get 2 over 1/2, which is 4. So our slope is 4. Alright, so now we need to figure out what that looks like. So if we have a slope of 4, Pythagorean theorem says that's the square root of 17, and here's another one. Square root of 17. Okay, so we want a unit vector tangent to the curve. So if it's tangent, both of these are tangents. So this vector right there is 1, 4. You know, 1, 4, but it's not a unit vector until you divide by the magnitude. So this one right there would be 1 over square root of 17, 4 over square root of 17. There's 1. That's tangent. These are the tangent ones. The other one right here would be -1, -4, and if we were going to make a unit vector, we just divide by the magnitude. So that also is tangent at the point, just going the opposite direction. If we're going to do normal, it would have to be perpendicular. It's going to look like this and like this. So our slope for normal is going to be not 4, but it's going to be -1/4. So if we were to draw those, and if I found the slope of -1/4, that means go down 1 over 4. (1/4), and it's -1. So that's again square root of 17. This one would be -4. That's 1 square root of 17. So they're my normals, or perpendicular. Here is 4, -1. So the normal unit vector would be 4 over square root of 17, -1 over square root of 17, and the second one over here, well, that vector is -4, 1, so it would be -4 over square root of 17, 1 over square root of 17. Those are your two normal unit vectors at that point.